Hey guys, welcome back. Welcome to Vedantu's JEE channel. How are you all? Welcome to this one short session. All the students who are taking a drop for this year's, as in the next year's JEE examination. This is a special series. आप सब लोग हमें 4 बजे मिलते हो डेली और आज का जो सेशन है दोस्तों, that is based on kinetic theory of gases and thermodynamics. So all those students who want a quick revision of these two chapters, the most important chapters of thermal physics, we are going to cover that today. Okay, so guys, share this video right away with your friends. Let them also watch along with you and do take the advantage of it. Okay, so guys, let's start off. And for those people who are new on the channel, let me start off with my introduction. This is me, your Suri Sir, and as you all know, I am a B.Tech from IIT Bombay. और इस चैनल पे मेरी जो आर्मी है वो मुझे मोगैम्बो बुलाती है. Why? Because when you will crack this examination of JEE, Mogambo खुश होगा. Okay? And if you are new on the channel, a lot of awesome things are happening on this channel. Very soon after this one short series, we are going to come back with your very favorite sprint series also, जहाँ पे हम लोग previous year questions को भी target करेंगे. And everything has been planned and we'll be there with you till the time you appear for JEE examination. So go ahead, subscribe to the channel, press the bell icon so that you never miss out on any of the videos, academic, motivational, as well as informative happening on this channel. Okay, so guys, this is one way of learning with Vedantu, and you all know that Vedantu has its own awesome platform also. So आप लोग अगर उस platform पे आके पढ़ना चाहते हो हमारे साथ में, तो let me tell you what exactly is the subscription plan for that. The subscription plan is called as Vedantu Pro और ये है वेदांतु का प्लेटफॉर्म जिसे हम वेव बोलते हैं. Let me tell you what are the benefits of joining Vedantu's platform. तो डेफिनेटली यूट्यूब पे तो आप हमारे साथ जुड़े ही हुए हो, आप अपनी जेई की प्रेपरेशन कर रहे हो, पर बहुत सारी चीज़ें हैं जो यूट्यूब में हम लोग नहीं आपको प्रोवाइड कर पाते हैं और वो सारी चीज़ें आपको यहाँ पे मिलती हैं. जैसे कि आप एक लॉन्ग टर्म बैच के साथ में जुड़ जाते हो, आपकी जेई की प्रेपरेशन थ्रू आउट द ईयर कंटिन्यू होती है इन अ वेरी organized and routine manner. There are so many teachers who are there to help you out in the class, outside the class with your doubts. There are so many tests and assignments that you appear for with us. In fact, एक बार वेदांतु प्लेटफॉर्म के कंटेंट के साथ जब आप जुड़ जाते हो तो आपको कोई और एडिशनल बुक या एडिशनल स्टडी मटेरियल परचेज करने की ज़रूरत भी नहीं पड़ती. एंड वन ऑफ द थिंग्स विच यू डोंट get on YouTube is the choice of your own language of communication. तो आप हिंदी या इंग्लिश किसी भी लैंग्वेज के बैच में आप अपनी जेई कंटिन्यू कर सकते हो प्रिपरेशन वाइज. उसके अलावा जब हमें कुछ भी रिवाइज करना होता है व्हेनेवर वी हैव आवर स्कूल एग्जामिनेशंस गोइंग ऑन, तो हमें यूजुअली रिकॉर्डेड सेशंस देखने पड़ते हैं यूट्यूब पे. बट देन on Vedantu's platform, we have so many micro courses which keep on running throughout the year, जहाँ पे आप subject wise नहीं, chapter wise भी किसी भी chapter को revise कर सकते हो. And when the time comes, you don't have to separately join a crash course or a test series. You naturally become a part of it. तो अगर इस amazing opportunity को miss नहीं करना चाहते हो, तो all you have to do, guys, is go on the link that is available in the description box and use this coupon code SMPRO and get an additional 50% discount on the subscription fees. All you have to do after clicking on this description, it will take you to a new page. वहाँ जाके आपको अपना standard वहाँ पे mention करना है कि आप 11th में हो, 12th में हो या आप repeat कर रहे हो, and then click on get the subscription plan. Choose the subscription ranging from 1 month till 12 month, and don't forget to use the coupon code in order to get an additional 50% discount. Okay guys, so I hope things are very clear to all of you, right? Let's go straight away dig into kinetic theory of gases and thermodynamics, that too in one shot. यहाँ हम क्या करेंगे? We'll have a quick coverage of theory and obviously the important formulae which are related to these two chapters, and then obviously there will be practice problems. हम बहुत सारे problems को practice करेंगे. आप लोग अपने pen और papers ready रखो so that you can solve the questions along with me. Okay guys, so let's dive in to the thermal physics chapter here. Guys, starting off with kinetic theory of gases. जब हम kinetic theory of gases की बात करते हैं तो obviously बहुत सारे postulates हैं जो आप सबको पता हैं. जो भी molecules gases के हम assume करते हैं for an ideal gas, they all are contained in a container. They are continuously moving, colliding elastically, no energy loss is happening in terms of these collisions. सबसे ज़्यादा important है एक equation जो पूरे chapter का heart and soul है, and that is PV equal to nRT, the ideal gas equation. यहाँ पे P is the pressure of the gas which is measured in Newton per meter square. Volume, yes, physics के point of view से बता रहा हूँ, will not be liters but meter cube. Number of moles, गैस कांस्टेंट, इसका वैल्यू हमेशा ध्यान में रखना 8.314, बट 8.31 तक भी अगर आप वैल्यूज पुट करोगे तो मोस्टली आंसर आ जाएगा, दैट इज जूल पर मोल पर केल्विन, एंड यस टेम्परेचर हैज टू बी इन केल्विन. Okay guys, so keep these units and the values in mind always and always. Don't confuse it with chemistry. Okay, also when we try to find out the pressure of the gas, the total pressure of the gas comes out to be 1 by 3 m into n becomes the total mass of the gas. Let's call that total mass of the gas to be m naught divided by the volume into V RMS square, which makes it 1 by 3 rho V RMS square. That's basically the gas pressure. Okay, और यहाँ से हमें जो गैस की मॉलिक्यूलर स्पीड्स हैं उसमें RMS स्पीड का हमें फॉर्मूला भी मिल जाता है. RMS speed is basically the square root of mean of squares of the speed of different molecules. It helps you calculate the kinetic energy of the gas. And V RMS का फॉर्मूला हमेशा ध्यान रखो, it is going to be 3p by rho, that is coming from the previous formula here. यहाँ को rearrange करोगे एक्सप्रेशन को, so you will be able to reach to the RMS velocity formula. और PV equal to nRT यूज करने पर this will come out to be under root of 3RT by m. Always remember, VRMS will be dependent for a gas only on its temperature. It does not depend upon pressure, because once you increase the pressure, the density of the gas will also proportionally increase, or vice versa, it will change. Okay. Similarly, if we speak about the average speed with which all the gas molecules travel, the V average value expression is 8RT by pi m, where m is the molecular mass in all these formulae, and then the speed with which you can say maximum number of molecules travel by, that we call as the most probable speed, comes out to be under root of 2RT by m. In general, the numerical value for a given gas molecule, the most probable speed will be the least, then average, and then the maximum value will be of the RMS speed of the gas. Okay, then we speak about the degree of freedom. Degree of freedom is basically the total number of independent ways in which a system can possess the energy, right? कितने फॉर्म्स में काइनेटिक एनर्जी गैस मॉलिक्यूल पजेस कर सकता है, दैट इज बेसिकली द डिग्री ऑफ फ्रीडम. इसीलिए मोनो एटॉमिक गैस के लिए जो डिग्री ऑफ फ्रीडम हम यूज करते हैं, दैट इज 3, विच आर ऑल ट्रांसलेशनल. ट्रांसलेशनल डिग्री ऑफ फ्रीडम होती है. डायटोमिक गैस मॉलिक्यूल्स अगर वाइब्रेट नहीं कर रहा है तो डिग्री ऑफ फ्रीडम का वैल्यू 5 यूज करेंगे, और अगर वाइब्रेशनल मोड भी कंसिडर कर लो तो 2 और ऐड कर दोगे, और टोटल 7 डिग्रीज ऑफ फ्रीडम हम यूज कर रहे होते हैं. ठीक है. उसके अलावा द लॉ ऑफ इक्विपार्टीशन ऑफ एनर्जी टेल्स यू दैट हाउ द एनर्जी ऑफ अ गैस मॉलिक्यूल इज डिस्ट्रीब्यूटेड. इट इज गोइंग टू बी इक्वली डिस्ट्रीब्यूटेड अमंग ऑल द वेरियस डिग्रीज ऑफ फ्रीडम. तो अगर मोनोएटॉमिक गैस मॉलिक्यूल है तो 3 अलग अलग तरह से टोटल एनर्जी डिवाइड हो जाएगी, टोटल एनर्जी डिवाइडेड बाय 3, and for diatomic accordingly 5 or 7 हो जाएगी. And with each degree of freedom, the energy associated with it is going to be half kT, where K is your Boltzmann constant, whose value is found as R by Na, which comes out to be 1.38 into 10 to the power minus 23. Okay, that's great. Similarly, अगर हम internal energy या kinetic energy के बारे में बात करें तो internal energy of the gas molecules is going to be F by 2 nRT. Okay? और उसमें F का वैल्यू जो है दैट इज गोइंग टू बी डिपेंडेंट अपॉन द एटॉमिसिटी ऑफ द गैस, N is number of moles, and R is the gas constant, T is the temperature. Okay, this is how you are going to talk about the internal energy. आगे जाके थर्मोडायनेमिक्स में हम देखते हैं कि ये NCV T के बराबर हो जाती है, और यहाँ से हमें CV का वैल्यू डिग्रीज ऑफ फ्रीडम के टर्म्स में F by 2R मिलता है. अभी थोड़ी देर में हम इसे यूज भी करेंगे. Okay? So when we speak about the entire molar heat capacity of the gas value, which is going to be something, I can say the most important agenda of discussion in KTG after PV equal to nRT is usually the molar specific heat at different processes. जब गैस को हम कांस्टेंट वॉल्यूम से ट्रीट कर रहे होते हैं तो उसको जो स्पेसिफिक हीट लगती है, द अमाउंट ऑफ हीट रिक्वायर्ड टू इंक्रीज इट्स टेम्परेचर बाय 1 डिग्री सेंटीग्रेड फॉर 1 मोल ऑफ द गैस, तो यहाँ पे हम n यूज कर लेंगे, दैट इज बेसिकली डिफाइंड एज Cv। एंड अगर यही गैस कांस्टेंट प्रेशर पे ट्रीट हो रही होगी तो फॉर्मूला बन जाएगा डेल्टा Q बाय n डेल्टा T। Okay, and surprisingly, unlike solids and liquids, the value of molar specific heat is not a constant. It's different for constant volume process, different for constant pressure process, infinite for isothermal process. Okay. Now, when we speak about relation between Cp and Cv, I'm sure सबको ये by hearted होगा. Cp का value हमेशा Cv से ज़्यादा होता है by a factor of R. Okay. One thing I forgot to tell you earlier, R का value अगर हमें कैलोरीज के पॉइंट ऑफ व्यू से कैलकुलेट करना हो, जूल्स में ना कैलकुलेट कर रहे हो, कैलोरीज पर मोल पर केल्विन हो, तो 2 कैलोरीज पर मोल पर केल्विन उसे यूज कर लोगे। और जैसा कि अभी मैंने बताया, Cv का वैल्यू होता है F/2R। थोड़ी देर पहले ही हमने देखा F/2R इज द वैल्यू ऑफ Cv फॉर अ गैस। तो अगर Cp कैलकुलेट करना होगा तो वो Cv प्लस R हो जाएगा, एंड दैट विल कम आउट टू बी F+2/2 इंटू R, राइट। तो अगर हमें गैसेस के लिए इन दोनों Cp और Cv का रेशो निकालना पड़े, जिसे हम गामा डिफाइन करते हैं, तो गामा फॉर एनी गैस विल बी Cp/Cv, एंड Cp इज F+2/2 into R and Cv is F/2R. That means gamma becomes F+2/F into R. याद रखने की जरूरत नहीं है, अगर Cp और Cv, इनफैक्ट सिर्फ Cv भी याद हो जाए तो बहुत इजीली उसे Cp के पॉइंट ऑफ व्यू से भी फाइंड आउट कर सकते हो और फिर गामा भी कैलकुलेट कर सकते हो फॉर एनी गैस फॉर दैट मैटर। ओके, तो अगर यहीं पे बताना हो तो गामा का वैल्यू फॉर अ मोनो एटॉमिक गैस, जिसके लिए डिग्री ऑफ फ्रीडम का वैल्यू 3 होता है, दैट विल कम आउट टू बी 5/3R। अगर गामा फॉर डायटोमिक गैस मॉलिक्यूल कैलकुलेट करेंगे फॉर डिग्री ऑफ फ्रीडम 5, तो दैट वैल्यू विल कम आउट टू बी 5+2, दैट इज 7/5R। और अगर वाइब्रेशनल मोड कंसिडर कर लोगे तो 9/7R वो वैल्यू हो जाएगी। ओके, अगेन नो नीड टू मेमोराइज। ओके, नाउ इफ यू हैव 2 or more gases mixed up together, then for that gas mixture, how much amount of heat per mole have to be given to increase the temperature of that gas by 1 degree centigrade? The value of Cv for the mixture will be calculated as N1 Cv1 plus N2 Cv2 by N1 plus N2, which is actually coming from the fact कि अगर यहाँ मुझे U1 और यहाँ U2 अमाउंट ऑफ इंटरनल एनर्जी इंक्रीज करनी है, तो टोटल इंटरनल एनर्जी का चेंज आ जाएगा U1 प्लस U2, एंड दैट विल बी N1 प्लस N2 इंटू Cv इंटू डेल्टा T। तो यहाँ से डेल्टा T दोनों केसेस में कैंसिल करोगे and you will eventually land up here, and accordingly the value of gamma can also be found. Okay? Cp का value हो जाएगा N1 Cp1 plus N2 Cp2 upon N1 plus N2, and that is why gamma will come out to be the one that you are seeing here. Okay, Cp by Cv mixture. Okay guys, so that is about the kinetic theory of gases. अगर बात करते हैं थर्मोडाइनमिक्स के बारे में, तो यहाँ पे सबसे ज़्यादा इम्पोर्टेंट डिस्कशन होता है फर्स्ट लॉ ऑफ थर्मोडाइनमिक्स का, तो वहाँ तक पहुँचते हैं थोड़ी देर में। उससे पहले समझ लेते हैं कि व्हाट आर द डिफरेंट टाइप्स ऑफ systems we define when we are treating the gases. We have open, closed और isolated system. Open system वो होता है जहाँ पे mass or you can say matter and heat both are exchanged with the surroundings. Closed system में only heat will be exchanged with the surrounding, and isolated system में no heat or no matter will be exchanged with the surrounding like a thermos flask. Okay? Based upon this, when we speak about the ideal gas equation, it will still hold true here also. PV equal to nRT is definitely going to be a very important expression to use when we are studying the laws of thermodynamics. And what is the first law of thermodynamics? It is nothing but law of conservation of energy. So let's just understand it in this way. If you give some delta Q amount of heat to a gas will either use that energy to increase its own internal energy, or it will try to do some work with the help of that. We can simply say that delta Q will be equal to delta U plus delta W. इसको ऐसे समझ सकते हो कि अगर आपको 10,000 rupees मिलते हैं, right? If somebody on Diwali gives you 10,000 rupees, then out of that 10,000 rupees, you can either use that entire money to get a fixed deposit done. एक एक ऑप्शन ये है आपके पास में, सेविंग्स कर लो, और दूसरा ऑप्शन है कि आप इसी पूरे पैसे को शॉपिंग में कंज्यूम कर लो, और तीसरा ऑप्शन क्या है, थोड़ा सा सेविंग थोड़ा सा शॉपिंग. दैट इज व्हाट बेसिकली इज फर्स्ट लॉ ऑफ थर्मोडायनेमिक्स. वर्क डन विल बी कैलकुलेटेड एज पीडीवी. तो हम इस एक्सप्रेशन को इन टर्म्स ऑफ पीडीवी भी रिप्रेजेंट कर सकते हैं. अब फर्स्ट लॉ ऑफ थर्मोडायनेमिक्स को हम स्टडी करेंगे फ्रॉम डिफरेंट डिफरेंट प्रोसेसेस पर्सपेक्टिव. कौन कौन से डिफरेंट प्रोसेसेस हैं थ्रू विच यू कैन एक्चुअली ट्रीट द गैस, वो हम लोग देखने वाले हैं. उससे पहले यस, वन वेरी इंपॉर्टेंट थिंग, always remember heat given to the gas will always be considered positive, work done by the gas will be considered positive, and if temperature of the gas increases then the internal energy of the gas will also be increasing and will come out to be positive in terms of change. On the other hand, if you take the heat out of the gas, that will be considered negative. If work is done by the gas, that will be considered that will be considered positive. If work is done on the gas, it will be considered negative. And if temperature decreases, the internal energy of the gas will also decrease and will come out to be okay. Now different processes, as I said, we'll be speaking about. For that, let's understand one very important thing कि अगर हमने कभी भी प्रेशर और वॉल्यूम का ग्राफ ड्रॉ किया तो एरिया बाउंडेड बाय दैट ग्राफ will give you the value of the total work done by the gas. So on the graph, if the volume increases, the area will come out to be positive because the work done will be positive. And if the volume will be decreasing, then gas will be compressing and the work done will be coming out to be negative. Okay. So अब different processes, isothermal, isobaric, isochoric, and adiabatic processes. We know that isothermal process is the one where temperature is going to be a constant, and if temperature is constant, go by PV equal to nRT for a given amount of gas, P into V has to become a constant, right? So P and V will be inversely proportional, will vary in a hyperbolic manner, while temperature and pressure, or temperature and volume, when you will try to draw the graph, the temperature will remain a constant. अगर आइसोथर्मल प्रोसेस है तो डेफिनेटली डेल्टा टी जीरो हो जाएगा, और अगर डेल्टा टी जीरो हो गया तो चेंज इन इंटरनल एनर्जी विल बी जीरो, विच सिंपली मीन्स इंटायर हीट दैट यू विल प्रोवाइड टू द गैस विल बी यूज्ड टू डू ओनली वर्क बाय द गैस. जितना भी पैसा मिला उससे गैस सिर्फ शॉपिंग करेगी, स्टोरेज कुछ भी नहीं करेगी, कोई सेविंग्स नहीं होगी. एंड हाउ विल यू कैलकुलेट द वर्क डन? It will come out to be nRT ln V2 by V1 or nRT ln P initial by P final can also be written. अगर ln को log में कन्वर्ट करना है तो 2.303 से मल्टीप्लाई कर दोगे. Okay, as I already said, internal energy change will be zero and this value will be equal to the amount of heat supplied to the gas. अगर work done positive आया तो heat supply किया गया है गैस को, work done negative आया तो heat गैस से extract किया गया है. Okay, second process is isochoric process, जहाँ पे volume of the gas will be a constant, and if that is the case then you can see that PV equal to nRT में V, N और R constant हो गए, P is proportional to T and P by T becomes a constant, so they will be proportionally increasing. On the other hand, volume will remain a constant. इस केस में क्योंकि volume constant है तो we can say that delta V zero हो जाएगा, और work done which is P delta V that will also turn out to be zero. So इस सिचुएशन में डेल्टा Q will be equal to डेल्टा U, मतलब जितना भी पैसा गैस को मिलेगा, currency is heat, it will only use it to store and not do any work. That is why the work done is zero. Internal energy change will come out to be NCV delta T, और जैसा मैंने कहा था कि इसी एक्सप्रेशन से हमें PV मिल जाता है F by 2R, राइट गाइस? तो वो प्रूफ भी हो जाता है, और यही वैल्यू इक्वल टू डेल्टा Q भी हो जाएगी in isochoric process. And you can always use this formula for CV and CV delta T to calculate the change in internal energy, as your internal energy of the gas is only dependent upon the temperature of the gas, not dependent upon any other factor. Okay? Third process is isobaric process, जहाँ पे pressure constant रहेगा. अगर pressure constant है तो volume will be proportional to temperature. राइट, तो P कांस्टेंट, N और R तो वैसे ही कांस्टेंट है यहाँ पे. V proportional to temperature, V by 2T becomes a constant. So we can say that the graph between V and T will be a proportional graph while pressure remains a constant. Now because pressure is constant but gas can expand, temperature can change, so यहाँ पे हर एक quantity delta Q, delta U and W तीनों नॉन जीरो हो जाएंगे. Work done will be calculated as P delta V, pressure is constant, or you can say nr delta t. Change in internal energy will still be equal to ncv delta t, and you will calculate delta q as ncp delta t. Okay? In fact, अगर यहीं पे ncp delta t को ncv delta t plus nr delta t लिख दो वर्क डन को, तो यहाँ से cp is equal to cv plus r मिलता है, जो एक्सप्रेशन हमने अभी थोड़ी देर पहले देखा था. Okay guys, वो प्रूफ भी यहाँ मिल जाता है. And then comes your adiabatic process, the process in which no heat is supplied or taken out of the gas. So apart from PV equal to nRT, what else will be valid here is this expression PV to the power gamma is a constant. You know that gamma is the ratio of Cp and Cv, and if you use PV equal to nRT and convert these expressions for temperature also, so Tv to the power gamma minus 1 will be a constant, and T gamma p to the power 1 minus gamma will be a constant. You have to just keep this one in mind. Rest you can use here. Okay. And as delta q is 0, so we can say delta u plus w will also be 0. So delta u is going to be minus of w, or w will be equal to minus of delta u. मतलब ये कि गैस को बाहर से कोई करेंसी हम दे नहीं रहे हैं, तो गैस को अगर शॉपिंग करनी है तो अपनी खुद की सेविंग्स को यूज करना पड़ेगा, या फिर अगर गैस को सेविंग्स बढ़ानी है तो खुद काम करना पड़ेगा in order to earn money. Okay. Also, the work done, which is equal to negative of delta u, is going to be p1 v1 minus p2 v2 upon gamma minus 1. Gamma is always greater than 1, or you can also write it as nr t1 minus t2 upon gamma minus 1. Remember this formula. Okay. Okay. Apart from that, if we speak about a cyclic process in which if a gas is treated through series of different you can say thermodynamic processes, the gas will always come back to its original state, such that the total change in temperature will be 0. And if change in temperature is going to be 0, then the quantity which solely depend upon temperature, that is internal energy change, will also become 0. That means in the cyclic, the amount of heat supplied will be equal to the work done. तो अगर वर्क डन पॉजिटिव आया तो गैस को हीट सप्लाई की गई थी, अगर वर्क डन नेगेटिव आया तो साइकिल में गैस से हीट extract की गई है. Okay. And yes, on the cyclic process, the device which works on the basis of it is Carnot engine, which tells you that if you take heat from a source which is at temperature T1, say that heat taken is Q1, you ideally want it to be converted to some mechanical work, engine will convert it into the form of kinetic energy, but practically some Q2 amount of heat will also be lost to the sink, or you can say to the surrounding. So the overall efficiency will be found as output upon input. Output is the work done, input is the heat supplied. Because it is a cyclic process, delta U is 0. So heat supplied is equal to the work done, which is equal to Q1 minus Q2 because of this process. Right guys? So efficiency ka expression can be written as Q1 minus Q2 by Q1, which is work done upon Q1. Or you can also write it as 1 minus Q2 by Q1, or 1 minus T2 by T1. Remember, T2 is the sink temperature, T1 is the source temperature. Okay guys, so that was a quick recap of KTG and thermodynamics. Let's go and see problem solving based upon what we have learned quickly in this session. Okay, so try to solve questions along with me. Okay, there will be different types of questions. पहला जो type है T1, that is based upon various speeds. Question number 1 says that at what temperature the molecules of nitrogen will have the same RMS velocity as the molecules of oxygen, which is at 127 degrees. RMS velocity का अगर formula देखें तो guys, V RMS is under root of 3 RT by M, which simply says that for two molecules to have same RMS velocity, the value of T1 by M1 should be equal to T2 by M2. अगर temperature for nitrogen पता लगाना है, its molecular mass is 28, temperature of oxygen is 127 degrees. Always remember that temperature you cannot put in degree centigrade. Add 273, comes out to be 400 Kelvin, divided by the molecular mass of oxygen, that is 32, and 4 से अगर हम divide करेंगे तो 7 by 8 is what I am getting here, and 8 will cancel it 50 times. So T1 comes out to be 50 into 7, that is 350 Kelvin. And 350 Kelvin में से 273 subtract करो, so value comes out to be 77 degrees centigrade. Always remember, you cannot work with degree centigrade temperature. You have to work with Kelvin as the temperature value. Okay, good. This one says that two vessels having equal volume contain molecular hydrogen at one pressure, as in 1 atmospheric pressure, and helium at 2 atmospheric pressure. If both samples are at same temperature, the mean velocity of hydrogen molecules will be. तो अगर V average की बात करें guys, so that is 8 RT by pi m, right? That means again V average only depends upon the under root value of temperature. That means V for H2 by V for helium will be under root of, they have same temperature, will be molecular mass of helium by molecular mass of hydrogen. That simply means V for H2 by V for He is going to be 4 by 2 in under root, that means root 2. We can say clearly that molecular speed, mean speed for hydrogen is going to be root 2 times the average speed of helium here. Right, everyone? Good. Next type of questions, T2, are based upon the internal energy. Remember, internal energy of a gas depends solely on the temperature. So here the average kinetic energy, which is also the internal energy of the gas at 27 degrees centigrade and 76 centimeter of mercury pressure, is 3 into 10 to the power minus 14 ergs for hydrogen. And we have to find out this kinetic energy for oxygen, which is at 127 degrees centigrade, and the pressure is also given. तो डोंट वरी, प्रेशर की हमें ज़रूरत ही नहीं पड़ने वाली. हमें पता होता है कि काइनेटिक एनर्जी ऑफ एनी गैस और इंटरनल एनर्जी इज गोइंग टू बी F/2 nRT. नाउ हाइड्रोजन एंड ऑक्सीजन बोथ आर डायटोमिक गैसेस, तो डिग्री ऑफ फ्रीडम सेम है. और इफ वी स्पीक अबाउट द नंबर ऑफ मोल्स, सो नथिंग हैज बीन मेंशन्ड. एवरेज वैल्यू की बात हो रही है तो मान लेते हैं नंबर ऑफ मोल्स आर आल्सो गिवन टू अस टू बी सेम, काउंट इज सेम. So we can say that kinetic energy is now looking like to be only dependent upon the temperature. So we can say that kinetic energy for oxygen by kinetic energy of hydrogen, that is 3 into 10 to the power minus 14, should be equal to temperature of oxygen, that is 400 Kelvin, and that of hydrogen was 300. This is 4 by 3 here, right guys? That means this 3 and this 3 gets cancelled, and kinetic energy for oxygen comes out to be 4 into 10 to the power minus 14 ergs. Right? That means the assumption was right. Number of moles are also same for both the gases. And when not mentioned, you will always assume that it is correct. Right? The correct answer is option D here. Okay. More questions based on internal energy. So at what temperature is the kinetic energy of a gas molecule triple the value of the same quantity at minus 23 degrees centigrade? We know that kinetic energy is proportional to temperature. So final kinetic energy is 3 times the initial kinetic energy. The final temperature is unknown. Initial temperature is 23 degrees centigrade. 273 में से 23 माइनस करोगे तो 250 केल्विन आ जाएगा. This gets cancelled. Temperature has to be 3 into 250, that is 750 Kelvin. और अगर डिग्री सेंटीग्रेड में कन्वर्ट कर दोगे तो 477 डिग्री सेंटीग्रेड is the value of the gas temperature at which the kinetic energy will become triple. Okay, cool. Now the gases, in the gases of diatomic molecules, the ratio of Cp by Cv is to be found. तो ये हमें याद होना चाहिए. Cp is F plus 2 by 2 into R. Degree of freedom for a diatomic gas molecule, if not mentioned, will be chosen as 5. So this is 7 by 2R. And if I speak about Cv, which is F by 2R, 7 by 2 was Cp. This comes out to be 5 by 2R. तो हमें जो गामा फाइंड आउट करने के लिए बोला गया है, Cp by Cv, that will be 7 by 5. That means 1.4. As I said, gamma will always be greater than 1 because Cp is always greater than Cv. Okay, that's why correct answer is option B. Okay guys, great. Now this one, it says that the specific heat of a gas at constant volume is 21.2 joules per moles per degree centigrade or per Kelvin, same value. If the temperature is increased by 1 degree centigrade keeping the volume constant, then the change in its internal energy for 2 moles of the gas. तो हमें CV का वैल्यू ऑलरेडी दिया हुआ है और हमें हीट कैलकुलेट करने के लिए बोला गया है. We have been asked to calculate the value of internal energy change, and we know that delta U is going to be NCV delta T. Number of moles of the gas are 2. CV value is 21.2. Change in temperature is 1 Kelvin or 1 degree centigrade. Linear scales हैं. This comes out to be 42.2 joules. Very simply, answer comes out to be option C. Okay, great. Now, type 3 questions which are based upon the gas mixtures. So we have a gas which consists of 2 molecules of O2 and 2 moles of oxygen and 4 moles of neon. So by the way, oxygen is a diatomic gas, neon is a monoatomic gas. Both have the same temperature. Neglecting the vibrational mode only, so degree of freedom was 5 for diatomic gas. The total internal energy of the system will be how much? So U, as I said, is going to be U1 plus U2. That is going to be F by 2 nRT for oxygen plus F by 2 nRT for neon. Okay. So degree of freedom for oxygen is already known. This is 5 by 2 into 2 moles into RT. Degree of freedom for neon is 3 by 2. Number of moles are 4 into RT. 2 and 2 cancels. 2 cancels is 2 times. So I have 5 RT plus 6 RT. That means the correct answer for the internal energy of the gas mixture is 11 RT. That means answer is option B. Okay. Next one. It says that 1 mole of a monoatomic gas and 3 moles of diatomic gas are put together in a container. तो अगर हम मोनोएटॉमिक गैस के बारे में बात करें तो डिग्री ऑफ फ्रीडम इज 3. डायटॉमिक गैस के बारे में अब याद हो गया होगा, डिग्री ऑफ फ्रीडम इज 5. वी हैव बीन आस्क्ड टू कैलकुलेट द मोलर स्पेसिफिक हीट एट कांस्टेंट वॉल्यूम. तो अगर CV की बात करें तो मोनोएटॉमिक गैस के लिए CV का वैल्यू है 3/2R एंड डायटॉमिक गैस के लिए the value for CV is 5/2R. Okay, F by 2R. तो अगर CV mixture हमें find out करना है तो that will be N1 CV1 plus N2 CV2 divided by N1 plus N2. Right, everyone? We have number of moles for monoatomic as 1. CV is 3/2R. Number of moles for the diatomic gases are 3 and that is 5/2R. Divided by the total number of moles which are 1 and 3, that means 4. Okay, so we get 3R by 2 plus 15R by 2, that is 18R by 2 to 4. That simply means 9/4R is the value for CV for the mixture. That means the correct answer is very simply option A. Okay guys, I hope you guys are solving this along with me. Have your notebook and your pen, right? Now, going to type 4 questions which are based on first law of thermodynamics. We have been given a set of processes where the gas is treated from initial to final state via 2 paths, IAF and IBF. For IAF, they have given you the value of heat supplied and work done by the gas, and for IBF, heat supplied is given and we have to find out the work done. Now, as you know that temperature change is same for both the processes and your internal energy change depends only on the change in temperature. It's basically the state function. तो पहले वाले पाथ में IAF में अगर हम डेल्टा U कैलकुलेट करें तो वो वैल्यू डेल्टा Q माइनस W आ जाएगी बाय फर्स्ट लॉ ऑफ थर्मोडायनेमिक्स. That is 49 minus 20. That comes out to be 29 calories. और ये वैल्यू सेम रहेगी फॉर द अदर प्रोसेस ऑल्सो. सो फॉर IBF you will say that the work done that process will be delta Q minus delta U. So delta Q is given as 36 and delta U is same as 29 only. This comes out to be 7 calories of work, and it is clearly visible कि अगर ये प्रेशर वॉल्यूम इंडिकेटर डायग्राम होता तो आई बी वाला जो ग्राफ का एरिया है वो कम आने वाला था. दैट्स व्हाई वर्क डन कम्स आउट टू बी less than half the value of work done in the IAF process. Hey guys, cool. Now this one, in this we have a gas again treated from state 1 to state 2 through path A, B, C and D, and we have been told that let Q, W and U be the heat supplied, work done and internal energy of the gas. Then in this process, which of these option will be right? So without even hesitating, can I say that the area for graph A will be maximum, then B, then C and then D? So we are sure that work done in A is greater than work done in B is greater than work done in C is greater than work done in D. And we know that delta U is same for all the processes because of the same temperature change T1 to T2. So we can say if delta U is same, so delta Q will come out to be delta U which is same plus W. तो जहाँ W ज़्यादा वहाँ पे Q भी ज़्यादा. That is why QA will be greater than QB, will be greater than QC, will be greater than QD. That's what makes correct answer as option D. Okay, great. Now the type 5 type of questions where we have different thermodynamic processes: isothermal, isochoric, isobaric or adiabatic. First one says that a cylindrical fitted with a piston contains 0.2 moles of a gas or air at 300 Kelvin. The piston is pushed so slowly. Whenever word slowly comes, the process is going to be isothermal, and whenever word suddenly comes, then the process becomes adiabatic. Okay, slow process is going to be isothermal, and sudden process is going to be adiabatic. Okay, guys. So in this case, when the cylinder remains in thermal equilibrium with the surroundings, find the approximate, or they have also said that the thermal equilibrium is there. That means the isothermal process is it. So we have to find out the approximate work done by the system, by the gas, if the final volume is twice the initial volume. So V2 by V1 is given to us as 2. Work done is going to be nRT ln V2 by V1. Number of moles are 2 by 10. 0.2, right? R is 8.31 multiplied by temperature, that is 300 Kelvin, and ln2, right? This comes out to be 2 into 8.31 into 30 because this 0 gets cancelled, and ln2 is 0.693. So you have 6 into 8 point, in fact 60 into 8.31 into 0.693. So when you do the maths, guys, you will get the value here as 345 joules. Do this calculation and find out the value. It should come out to be option B for you. Okay, great. Now this one, in this one we have a monoatomic gas whose gamma is given at a pressure P and it is suddenly compressed. I told you, suddenly means adiabatic process, always remember that. Slowly means isothermal process. So the volume becomes 1 by 8th of its original volume. Okay, so the pressure of the gas will change too. We know that PV to the power gamma is a constant. That means P1 by P2 will be V2 by V1 to the power gamma, right? And we have to find out the final pressure, right? तो एक काम करते हैं, उल्टा जाते हैं. P2 by P1 will be equal to V1 by V2 to the power gamma, so that I can write P1 as P only. P2 by P will be equal to V1 which is V, V2 which is V by 8, and gamma is 5 by 3. That means it is 8 to the power 5 by 3. That means P2 is equal to 2 to the power 3 power 5 by 3 times the pressure. That means this is 2 to the power 5p, and answer comes out to be 32 times the original pressure. Obviously, अगर PV to the power gamma is a constant, that means अगर volume कम होगा तो pressure definitely increase हो जाएगा. Okay. One more question. This says that a container having 1 mole of a gas at a temperature of 300 Kelvin has a movable piston which maintains at constant pressure, and that pressure is 1 atmosphere. The gas is compressed until the temperature becomes 127 degrees centigrade, and the work done in this process is to be found. Guys, हमें टेम्परेचर चेंज बताया हुआ है, नंबर ऑफ मोल्स हमें पता है और सीपी का वैल्यू पता है. हमें मालूम है कि सीवी का वैल्यू भी हम फाइंड आउट कर सकते हैं एज सीपी माइनस आर, और क्योंकि ये कैलोरी पर मोल वाला फैक्टर है तो ये हो जाएगा 7.03 माइनस 2, दैट मीन्स 5.03 कैलोरी पर मोल पर केल्विन इज द वैल्यू ऑफ सीवी. तो अब मैं यहाँ से डेल्टा क्यू कैलकुलेट करूंगा एज एन सी पी डेल्टा टी, और डेल्टा यू कैलकुलेट करूंगा एज एन सी वी डेल्टा टी, एंड देन फर्स्ट लॉ ऑफ थर्मोडाइनमिक्स टू कैलकुलेट द वैल्यू ऑफ वर्क डन. Number of moles are 1. This is 7.03. As you can see, answers are in joules. So 4.2 से multiply कर दो. Change in temperature is simply 100. तो इसे जब simplify करते हैं तो this comes out to be 2952 joules. Close to this value हमें ये value मिलती है delta Q की. अगर delta U find out करेंगे तो that will be N CV delta T. Number of moles 1. CV का value 5.03 into 4.2 into 100. तो डेल्टा यू का वैल्यू आप सॉल्व करोगे तो 2112 जूल्स हमें वो वैल्यू मिल जाती है. दैट मीन्स वर्क डन इज गोइंग टू बी डेल्टा क्यू माइनस डेल्टा यू, दैट इज 2952 minus 2112, and when you simplify this will come out to be 840 joules. Okay, and the answer will be option B. Okay, great. Now these were type 5 questions, and now the last type, that is T6, type 6 questions based on the Carnot engine. Question says that a Carnot engine whose efficiency is 40% takes heat from a source which is maintained at 500 Kelvin. It is desired to have an engine of efficiency 60%, then the source temperature must become what? So guys, efficiency is 1 minus T2 by T1, और एफिशिएंसी पहले हमें दी हुई है 40%, दैट मीन्स 4/10, एंड दिस इज 1 माइनस T2 बाई 500 केल्विन. तो यहाँ से हम T1 फाइंड आउट कर ले, सॉरी T2 फाइंड आउट करते हैं, दैट इज द सिंक टेम्परेचर. तो T2 इज गोइंग टू बी 500 इंटू 1 माइनस 4/10, विच कम्स आउट टू बी 500 इंटू 6/10, दैट मीन्स T2 का वैल्यू हमें मिलता है 300 केल्विन. तो सिंक का टेम्परेचर जो है गाइस वो हमें मिल जाता है एस 300 केल्विन. तो ये तो वही मेंटेन होगा. अब ईटा डैश जो है वो हम 60% मतलब 6/10 करना चाहते हैं, एंड 1 माइनस T2 बाई T1 डैश. तो T1 डैश हमें पता लगाना है. तो यू हैव 6/10 is 1 minus 300 by T1, that means 300 by T1 comes out to be 4/10, और T1 dash comes out to be 3000 by 4, that is 1500 by 2 और 750 केल्विन. तो अगर टेम्परेचर को, सोर्स के टेम्परेचर को 500 से 250 केल्विन इंक्रीज करके 750 केल्विन कर देंगे तो गैस का जो इंजन है उसकी एफिशिएंसी 40% से 60% हो जाएगी बढ़ के. करेक्ट आंसर इज ऑप्शन सी. एंड नाउ दिस वन is the last question, and I would want you people to try this at home as your homework question. Okay? Question में हमें Carnot engine का T2 और T1 टेम्परेचर दिया हुआ है, उसका वर्क डन पर साइकिल हमें बताया हुआ है, and what is the amount of heat energy supplied to the engine from the source is what you have to find out. So guys, efficiency 1 minus T2 by T1 will be equal to W by Q1. हमें ऑलरेडी T2, T1 और W दिया हुआ है. Try to find out the value of the heat supplied to the engine, that is Q1. Okay, so do solve this question guys, and later on tell me your answer, which of these options is what you are getting right, in the comment section of this video. I will get back to you with the correct answer very soon. Okay guys, cool. So I hope this must have been a very good one shot and a quick revision for people who are targeting JEE 2021. Okay, और अगर इससे पहले के भी चैप्टर्स हैं या और कोई चैप्टर है जो आपने मिस किया है and you want to cover up those topics in detail, then there are two methods. एक है free of cost obviously, the other one might involve some money for you and it could obviously result in a better solution. So I'll show you both. You choose what you want to follow here. Okay, guys, the first method is to go on the channel playlist. और चैनल पे आपको दो प्लेलिस्ट मिलेंगी, एक है जीत लो 2022 और एक है जीत लो 2021। तो 2022 जो है वो 11 स्टैंडर्ड के टॉपिक्स हैं और जीत लो 2021 जो है वो 12 स्टैंडर्ड के टॉपिक्स हैं। आप दोनों ही सीरीज जो है उसमें पूरी फिजिक्स और पूरी केमिस्ट्री ऑफ जेई एग्जामिनेशन को यहाँ से रिकैप कर सकते हैं। ओके, उसके अलावा अगर आप रिकॉर्डेड सेशंस नहीं देखना चाहते, आप टेस्ट भी देना चाहते हो, आप रेगुलरली एक स्टडी मटेरियल एंड डाउट सॉल्विंग के साथ जुड़े रहना चाहते हो, you can join a freshly started crash course with us. This crash course, I'll tell you, it involves entire coverage of JEE main syllabus. When I say entire, I mean entire physics, chemistry, maths, not just physics. And that too will happen in 90 sessions, properly planned, properly designed, specially designed to keep the repeating students their requirement in mind. You will have unlimited access to the doubt solving with the help of our doubt solving app between 8 in the morning as early as that to 11 p.m. as late as that. Okay, you will have 10 full syllabus and 10 part syllabus test, online test, all of them for you to make you better prepare for your JEE examination. Always get to know amazing tips and tricks from your master teachers to crack JEE examination. Also, this platform Wave is not a one-way teaching, it's a two-way interactive platform जहाँ पे students अपने questions, अपने doubts भी classes में पूछते हैं और simultaneously वो doubts answer भी होते हैं. Okay, so guys, this batch has started on this Monday only. The fees for you guys is not 10,000 but it is 8,000 if you use this coupon code SMCC to avail this 20% discount on the enrollment fees. कैसे ज्वाइन करना है? The link for joining is available in the description box. Go for it, join the crash course and improve your chances significantly to crack JEE 2021. Okay, in case of any doubt you can write down that in comment section also. Apart from that, इस session के assignments will be uploaded by the end of the day. You will find the solutions of the assignments on Telegram channel along with the सेशन PDF, जो सेशन में मैंने नोट्स यूज़ किए हैं वो आपको मिल जाते हैं एज इट इज़। उसके अलावा डेली अपडेट्स भी हम लोग वहाँ शेयर करते हैं। तो ये सब होता है ऑन द टेलीग्राम चैनल ऑफ वेदांतु जेई, जिसके लिए भी अगर ज्वाइन करना चाहते हो, अभी तक नहीं किया है, तो डिस्क्रिप्शन बॉक्स में जाके यू कैन फॉलो दैट लिंक एंड कम टू द टेलीग्राम चैनल ऑफ आवर्स। ओके गाइस, so this brings us to the end of the session. अगर सेशन में मज़ा आया तो go ahead, press that like button, share with your friends, and if you are new to the channel, do subscribe and press the bell icon so that whenever your Mogambo comes live, you don't miss out on any of that information. Guys, I'll see you very soon with another one short session. Till then, keep studying, keep solving the questions here, and keep smiling. Stay safe. Bye bye, guys.